Now that we've seen how to do a depth-first traversal of the nodes in a document, let's now do a breadth-first traversal. Here in this diagram that you see, we have the same XML node structure that we had in the previous example, only now we're going to traverse the nodes in a separate order. This is called breadth-first. And in breadth-first traversal, you pick a node to start at, whether it's A here or B here, whichever one. And the idea is you visit all of the node's siblings and child siblings in order. So, for example, if we were to start off at node A, we would first visit node B, and we would process B right at this moment. We wouldn't wait to come back to it. Then we would travel over to H, and we would process node H. Now we've now processed all of the nodes in sibling order under A. Then we would travel all the way over to C, because now we're going to go do all of B's child siblings. And from C, we would go to D, and then over to E. And then from E, we would go right back to the left, go down to F, and over to G. And when that happened, we would travel all the way back over to I, and then do J. So in this case, the node visit order would be A, and then B, and then H. And then we would do C, D, and E as the siblings underneath B. And then we would do F and G as the siblings underneath C, and then we would go over to I and J, which are the sibling nodes underneath H. The algorithm that does this is here. This is called a breadth-first traversal, and it takes the node that we want to start at, and the first thing we do is check to see if the node is not equal to null, and that it actually has some child nodes that we can process. So we have our for loop, and we say for the node equals node first child, and we make sure that the node is not equal to null. And when we want to advance the node, we go to get the next sibling. And now what we're doing is we're changing the visit order to process it right here up front before we go down to the next level. And this is my string that I'm building up to illustrate the order in which we're visiting the nodes, but the code you would write in here is whatever processing you wanted to do for the node when it gets visited. Okay, so that for loop is going to execute, and it's going to do all the sibling nodes. Now we need to go down to the next level, which is where we get the first child for the node, and we have the same kind of loop, only now we do that recursive function call right here. So we call this function back into itself, only this time we're going to process all of the child node siblings. So once again, it's probably best to see this in action in order to understand it. Okay, so here we are in the code for the breadth first example, and you can see it's the same code that we looked at in the depth first example. The difference is that the function name is changed, but everything else is the same. The sample document structure is the same, and I'm including the traversal library so I can do this cross-platform. So this is the function we need to write here. The load XML data is going to load our sample document structure using the parser, and after this function gets finished, we're going to display an alert with this string in it. Okay, so let's write the code. And the code is going to look something like this. We're going to say if onode is not equal to null and onode that has child nodes, then we're going to do a loop, and the loop will say for the node equals onode dot first child, the node not equal to null, and the node equals the node dot next sibling. Okay, so inside this loop, we're going to write gs visit order plus equals the node dot node name plus, and some pretty printing to make it look good. So that's what takes care of visiting the nodes and processing them. Now we need to process all of the sub-child nodes. So we're going to do for, and essentially it's the same loop. So I'm just going to copy this and paste that in. And I'm going to put the braces in. And now I'm going to call breadth first traversal with the node. That's the function, so let's see how it works. I'm going to view this in the browser. And you can see that the nodes were visited in the sibling order. So we did node A, and then we did node B, and H, and then C, D, and E, which are all underneath B. Then we did F and G, which are underneath C. And then we did I and J, which are underneath H. So things executed in the order that we did them. Oh, just before I go any further, let's make sure it works in Firefox. That way I can say that it did. Okay, yeah, same results. A, B, H, then C, D, E, then F, G, and then I, J. Okay, so you're probably wondering if you can maybe change the order in which things operate. Instead of going left to right, can you go right to left? And the answer is yes, you can. If you wanted to go right to left, for example, instead of doing first child, you would do last child. And then instead of next sibling, you would do previous sibling, and so on. And that would give you the reverse order. Now that we've seen how to do breadth first traversal and depth first traversal, let's move on to the rest of our DOM algorithms.